not covering for a long time. It's also a very simple theorem, but because we have already covered 5, 6, so then we thought that let us not have more. There is one or two more which we have at some places. There is one duality principle which is very close to source transformation. Okay, so let us start with our topic today. So we are going to introduce or refresh, we should say, the concept of capacitors and inductors and how to analyze circuits with capacitors and inductors. So capacitor is basically a device which is having two conducting plates separated by insulator or dielectric. This is the circuit symbol, and when the current is flowing or when there is some charge, a voltage is developed and charge is equal to CV. This C means capacitance is basically the ratio of charge on the plates of capacitor to the voltage difference between two plates, and it is measured in farads. So C is also given by epsilon A by D, where A is the area and D is the distance between two plates. Current and voltage relations. Current is given by dq by dt, and q was CV. C is a constant, so C dV by dt. So current and voltage relation is a differential equation, and if you integrate this equation, then you get that voltage is equal to 1 by C integration of I dt. And if you want to integrate for a finite amount of time, then 1 by C from t0 to t I dt plus the voltage at t0. Okay, or t naught, whatever you can call it. Work done to have a potential across capacitor is 1 by 2 CV square. These are all the things that you already know, and we are revising and refreshing. If I have a capacitor voltage and we are changing it slowly, charging it and discharging it and then keeping constant, this thing can work. But if we want that this is my capacitor voltage and immediately it will come to zero, this is not possible. Abrupt changes are not possible in the voltage. Okay, and one more thing, if you look at this equation, if voltage is constant, that means dV by dt is zero, that means current is zero. So if the voltage across capacitor is a constant value, then the current in the capacitor will be zero. If the current is zero, that means capacitor will act like open circuit. Okay, so capacitor is like open circuit to DC values, DC voltages, DC current. The voltage on capacitor must be continuous and it cannot change abruptly. Ideal capacitor does not dissipate any energy, but if you take non-ideal capacitor, then there is a parallel leakage resistance of very high value. It is in mega ohms. Okay. So there is a very simple question. You would have done a lot of such questions earlier. Determine the voltage across 2 microfarad capacitor if the current is this. So it's a very simple thing. I am given the current value and we are asking the voltage. So voltage is 1 by C I dt plus V naught. V naught is not given, so I can assume it 0. It is already given. Okay, assume that initial voltage is 0. So if it is given 0, fine. So you just simply integrate this. When we integrate this, we get this as our answer. Okay. So as you can see that voltage across this capacitor at t equal to 0 will be 1 minus e raised to power 0 is 1, right? 1 minus 1, 0. And after that, this value, as t will increase, what will happen to this factor? Will it increase or decrease?
Sir, decrease, decrease,
Decrease. Decrease.
decrease, decrease.
Okay, so initially it is 1, and slowly as t tends to infinity, this will go
It
to
will
0,
tend to zero.
right?
Yes, sir.
So the
Yes.
difference, which is 0, it will slowly rise to 1. Okay, and it will reach 1 slowly. Fine.
Yes, sir.
So there is another question, very simple. You are given that there is a current through capacitor whose value is 200 microfarad. Voltage across capacitor, this is voltage across capacitor, is shown like this. We are asking that at every time, that means t from 0 to 1, 1 to 3, 3 to 4, in all these time durations, what is the current through this capacitor? So we said, okay, that is not a problem. I is equal to C dV by dt, and you have already given me the equations of voltages. If you have not given me equation, at least you have given me the graph. From this graph, I can get these equations. Once I have these equations, so first is 50t. So C dV by dt, okay, I get these values. And when I multiply with C also, C is outside. When I bring this C inside, so these are my values. Okay, so these are the things which are related to the voltage current relation of capacitor. Now what we are doing, we are putting our capacitor into a circuit. This is a circuit which we have, and there is a 6 milliampere DC current source. Okay, and only one source is there. There is one capacitor here, there is one capacitor here. We are asking, obtain the energy stored in each capacitor. Okay, what is the value or formula for energy stored?
Sir, half CV square.
Half C square.
C is known.
Capacitor and V square.
Okay. C is known.
Yes, sir.
V I have to calculate. That means the question is, I have to calculate what is the voltage across each capacitor. Okay, and whether I measure plus this side minus this side or plus this side minus this side, it will not matter, because eventually it will be V square. Is it okay?
Yes,
Yes,
sir.
sir.
Yes,
Fine.
sir.
Yes, sir.
Now we had assumed that for DC values, whether it is a current or voltage, capacitor will act like open circuit. So open circuit means remove this, remove this. That means this is my V1 that I have to measure. Voltage across these two terminals, that means voltage across 2 kilo ohm. Similarly, I open circuit this one. Current in 5 kilo ohm will be 0. I can remove this, and voltage across this is same as voltage across this. Is it okay?
Sir, sir, we
Yes.
are removing the capacitor considering that it has charged fully, right?
Okay.
Sir, I'm asking this that we are removing it because of this now.
At t
No,
is
no.
equal to infinity, we are doing this question.
Yes, because DC values always means t is equal to infinity. T is
So,
Okay,
sir,
okay.
equal to infinity signifies that all the fluctuation in my voltage or current values, they have settled down. Okay.
yes, sir.
So that is also called steady state.
Yes, sir. So, sir, in steady state, the capacitor gets charged fully.
Okay, voltage is constant.
So, sir, that is why we can.
That is why I is equal
We
to
are
C
taking it
dV.
like brake
I is
wire.
equal to C dV by dt. If V is constant, dV by dt is 0. I is 0. If I is 0, that means open circuit.
Open circuit, yes, sir.
Okay. That
Yes,
is
sir.
the reason I explained 2-3 slides back also.
Yes, sir.
Now this is a simple circuit with us. There is a 6 millivolt, 6 milliampere current, 3 kilo ohm this side, and 2 and 4, 6 this side. That means in this 2
So
milliampere will go, in this 4 milliampere will go. Is it okay?
yes, sir.
2 milliampere into 2 kilo ohm, 4 volt, and 2 milliampere into 4 kilo ohm, 8 volt. Is this also clear? So V1 will be 4 volt, V2 will be 8 volt. After that, you can calculate W1, W2, and all.
Sir, can you explain 4 and 8 again?
6 milliampere is divided into two branches. One branch is having equivalent resistance of 2 plus 4, 6. One branch is having equivalent resistance of 3.
Yes.
So what is the current in this branch? Opposite resistance 3 divided by total resistance 3 plus
9.
6,
9.
3 plus 6 into total current.
Yeah.
So 1 by 3 of 6 is 2 milliampere. So in this branch 2 milliampere is coming. 2 milliampere into 2 kilo ohm, 4 volt. 2 milliampere into 4 kilo ohm, 8 volt.
Okay, sir.
Okay. So now when we have capacitors in parallel or series, how to calculate equivalent, that also is known to you. When they are in parallel, equivalent capacitance is calculated by the summation. Okay. And when they are in series, then 1 by C equivalent is 1 by C plus 1 by C2 and so on. Is this okay?
Yes, sir.
Right. Now coming to inductor. Inductor is another energy storing device, very similar to capacitor but slightly opposite in all the behaviors. Inductor is basically a coil which is of conducting wire, and voltage across inductor is L di by dt. That means if I is constant DC value, then di by dt means 0, V means 0. That means inductor will act like a short circuit for DC value. Is it okay?
Yes, sir. Yes, sir.
After that, you can have different formulas which are already known to us, that what is the formula for inductance, what are the units of inductance, and I do the same thing. L is equal, I is equal to L di by dt, V is equal to L di by dt. If I do the integration, that means I is equal to 1 by L integration V dt. And actually it should be plus current at T naught. And work done across inductor is also 1 by 2 Li square. So
Sir,
when we note, yes,
sir, in the previous slide, how is IP not coming? How
IP
is
not
how is limit changing?
limit
Minus
changing
in,
means,
sir, we change
okay,
minus.
this one
Yes, sir.
to this one.
Yes, sir.
So we are saying if we are calculating the total current from minus infinity to T, it is I. And what will be the current from minus infinity to T0? That will be 1 by L integration minus infinity to T0 Vt dt. Is it okay? I am not changing the limit. I am just saying the current till T0. Is this okay?
So why first limit is minus infinity?
Because everything starts from minus infinity. If you are going in
Okay,
the past,
okay, sir.
So
okay,
T0 is at what time?
that can be anything, and that is what we will clear in the future lectures. So let us consider one question. There is one inductor which is connected to the circuit with a switch. I press the switch at time t equal to 0. So here t0 is 0 second. Okay, sometimes the circuit can be one resistor, one capacitor, one inductor. They are connected with with respective switches. I switch on the resistor at t equal to 0. I switch on the capacitor at t equal to 2, and I switch on the inductor at t equal to 4. So T naught for resistor is 0, T naught for capacitor is 2, and T naught for inductor is 4. After that, I say at t equal to 7, I switch off inductor. So now T naught for inductor is 7, and I will do fresh calculations. You will have all these questions, okay? T naught is basically the time of change when the inductor current starts changing. Before T naught, everything was stable. Is it fine?
Yes, sir.
Okay, next. So that thing we have already explained. The inductor will act like a short circuit to DC, and current in the inductor will not change immediately. Okay, so remember one thing: capacitor, voltage; inductor, current. Capacitor will always be controlled by the voltage. Voltage will not change abruptly. Okay, and in the inductor, current will be your driving factor. In capacitor, the relation is also derived from voltage. The power or work done is also dependent on voltage. In capacitor, it is dependent on current. So just like ideal capacitor, ideal inductor will not dissipate anything, and if it is not ideal, it is a non-ideal inductor, then there will be a series resistance and parallel capacitor. This is the model for practical inductor. So similar questions for all of you. I have given that the voltage across 5 Henry inductor is Vt, and it is 30t square for t greater than 0, and it is 0 for t less than 0. Find the energy stored within this time period. Okay. Now what was the yes?
Sir, I have not understood this equation. I is equal to 1 upon L T naught to T, that limit I T naught 1 part.
Okay, fine. So let me write the equation again. This is the equation which we said. I am rewriting it. I is equal to 1 by L minus infinity to T V dt. This is the current from minus infinity to T. Is it okay?
Yes, sir.
And what will be the, so this is the equation for I of t. I of t means current at time t. Is that fine?
Sir, how can time be minus infinity?
Yes, sir. Minus infinity, not understand.
Why cannot time be minus infinity? Tell me, when were you studying in class 12?
Sir,
Minus,
is it like
minus 20.
sir, is it like we haven't start the stopwatch and then before that circuit was
Yes,
doing
that is
something
what
and
we
all?
are saying. Time,
Okay.
negative time is not a new thing to you. When
Okay,
were you
sir.
there in class 10? Minus 2 years, right?
Okay, sir, got it.
So minus infinity time means I am starting my circuit at 5 p.m. What was happening at 1 p.m.? It is minus 4 hours.
Yes, sir. Yes, sir.
Okay. So we set a reference, and according to the reference, plus and minus time will be there. So now I say, what will be I of t naught? It will be minus infinity to t naught. Okay. Now we are saying at t naught, everything is stable. So what is the value of this stable current? Minus infinity to t naught v dt. Okay, I got it. There is no constant, nothing. Now I want to ask, okay, what is I of t for t greater than t naught? I say, first of all, take t naught, and then Calculate the remaining one from t naught to t v dt, whatever is happening. And 1 by L is there. Is this fine now?
Yes, sir.
Whatever happened up to t naught, I have the value. After t naught, whatever is happening, I will calculate. And t naught does not mean it is always 0 second. It can be 5 second, it can be minus 5 second, it can be anything. Is that fine? Now,
Yes.
Yes, sir, got it.
now we are asking that these are my voltage relations for different amount of time. Tell me from 0 to 5 second how much energy is stored. So I
Sir,
said yes.
sir, if we take t naught equals to 1, then what will be the value?
It will depend on the circuit, right?
Like in this question, if t naught is 1, then I will cut out.
If T naught is 1, then this is the equation, okay, which is telling us that for t less than 0, this is my value. And then from t, see, these are the negative values of time, these are the positive values. From 0 minus infinity to 0, voltage is 0, okay.
Yes, sir.
After that, it is increasing like this.
Yes,
Is
sir.
this fine? So
Hmm.
T naught will be here if you take T naught equal to 1.
Yes, sir.
So take this equation.
Like if I place t naught equals to 1, I is a variable and I will cut out now, sir.
Wait,
But
let me complete this numerical. I'll come to your, okay.
okay, sir.
So first of all, we are assuming that for t less than 0, and this is v of t is 0, and after t greater than 0, it is going exponentially like this. Fine. Now I say, okay, I is 1 by L integration t naught to t vt dt plus I of t naught, and L is 5. What is the value of I t naught? That means what is the value of current at t equal to 0? Up to this point, we were not giving any voltage, any current. But here it is not mentioned also. So one thing please remember, if the voltage across capacitor is 0, does that means the current in the capacitor is also 0?
No, sir.
No. So this is our assumption here. It should have been given clearly that the initial current in the capacitor is 0. Okay. So that is the assumption we are making, that initial current is 0. When I take that initial current 0, because it is not given in the question. Okay. If it is not given, I can assume it. And mostly you will assume 0. And then I put 1 by L means 1 by 5 30 t square dt. That means 30 will come out with 5. So 6 into 1 by 3 t cube, and integration from 0 to 5, because we are asking from 0 to 5. And when I do these calculation, I get basically this. And in this, if I put t equal to 5, then I will get the energy accordingly. 1 by 2 Li square. Is that fine?
Sir?
Now coming to your question, if t is 1, if t naught is 1, this is my current. Let me write the current equation. Current equation is 0 for t less than 0, and it is 2 times t cube for t greater than 0. So at t equal to 1, I of 1 is 2 ampere. Is this okay? That means I of t naught for is 1 ampere, sorry, 2 ampere. Then the initial current will be given as 2 ampere.
from like we took the limits from t naught to t. So like it will be like 5 cube minus 1 cube. Isn't it be like that, sir?
After that, it will be there. Right now, I am calculating what is T naught. You were asking what is T naught. If T is equal to, if T naught is 1. If T naught is 1, then the value of T naught will be 2 ampere. If T naught is 2, it will be 2 into 2 cube.
Sir,
It's from the zero. Like if we are taking t naught equals to 0 and t equals to 1 and 2, right?
No, you have to understand what is the meaning of T naught. T naught means my starting point.
Yes, sir.
My starting point is completely different from my frame of reference. I can say I am starting my circuit at t equal to 0. Okay,
Yes, sir.
fine. But
Hmm.
in the circuit, there can be multiple elements. Just a moment. Okay, there can be multiple uh, points when the circuit can start. It can start at 2 seconds, 4 seconds, minus 4 seconds. Fine. We
Yes,
will
sir.
very specifically ask you for this inductor. These are the equations, and time equal to 4 seconds. The current in the inductor is 4 ampere. Okay,
Okay.
fine. After that, after 4 seconds, I switch on the inductor and
Hmm.
then tell me what are the equation of current and voltage or power or work done across inductor. Okay, let us wait for one or two more questions and it will be
Sir,
more clear. Yes,
sir, you told that when Vt is equal to 0, It may not be 0, but when you took the example of T naught is equal to 1, then you took It is equal to 0.
no,
Yes,
no.
sir.
What are you saying?
You told that when Vt is equal to 0, then It may not be 0. But
Yes, yes.
when you were answering his question, you took T naught at 1 second, you took It is equal to 0.
Okay. I said I don't have any information that what is happening before t equal to 0. Okay, if you don't have any information, what is the best number to assume? 0, right?
Sir, we can take it 0, right? Because like we are integrating from minus infinity to 0. Okay,
Mhm.
so it's a definite integration. If it
Yes.
would be an indefinite integration, then we can see that there could be a constant c, which is indefinite integration constant. But
Right.
definite means we
That
can
is
take it
fine, but
0 easily.
another reason from the circuit point of view is if I have no information about a particular time and I have to assume, if I assume 0, there is a solid ground to say that no power source was attached to the circuit, no voltage source, no current source. So it will have 0 voltage, 0 currents. How can I assume that there was 5 volt or 5 ampere current
Yes, sir.
flowing in the, okay? So that justification will be very difficult to defend. But if we have to assume, then assume 0.
Sir, I have a conceptual doubt. When Vt is equal to 0, why not It is equal to 0?
Because I is equal to L di by dt. V is equal to
I can be constant.
V is equal to L di by dt. If I is constant 2 ampere, di by dt is 0, V is 0. So if V is 0, does not mean current is 0. Okay.
Sure, sir. It is constant.
Hmm. So I have a circuit now which is having a combination of inductor and capacitor. Both of them are there. So there is one capacitor here, there is one inductor here, and we are asking what is the voltage across this capacitor and what is the current flowing in this branch if this is a 12 volt source attached here and 145 ohm resistances they are there. So we say Okay, these are DC conditions. DC conditions means
T
capacitor
infinity.
will act like as open
Open
circuit
circuit.
and inductor will act like as short
Closed.
circuit.
Close.
So this is my new circuit. This is removed. 1 and 5 ohm in series. So total 6 ohm. So this current will be 2 ampere. Is that okay? 2 ampere is flowing. So the current IL is 2 ampere. Is that fine?
Yes, sir.
Yes, sir.
After that, we are asking what is the voltage across this capacitor. Voltage across this capacitor is the voltage across these two terminals. And these two terminals, they are parallel to 5 ohm. Voltage across 5 ohm is 2 into 5, 10 volt. Is that also fine?
Yes, sir.
After that, I can ask a few more things like what is the work done or energy stored in the capacitor, what is the energy stored in the inductor. Those are easy calculations.
Sir,
Yes,
sir, as the current is direct current, it means it's not changing. That's
yes,
why across the inductor there is no voltage drop, right?
yes. There is no voltage developed because initially there was some voltage which was changing. V is equal to L di by dt. When the current is changing, voltage is developed. When the current is constant, voltage becomes zero.
Okay, that's why we only took 5 ohm
Same
voltage drop.
reason, yes, same reason is for capacitor. I is equal to C dV by dt. When the voltage in this branch is changing, some current will flow in this branch. After some time, the voltage will be constant. When the voltage is constant, or you say capacitor is fully charged, when the voltage is constant, dV by dt is zero, current is zero, and then we say this is open circuit.
Okay, sir.
Okay?
Excuse me, sir.
Yes.
Sir, you are considering that there will be some current flowing in the 4 ohm resistor, right?
No, why it will flow? Initially, it will flow very beginning when you start the circuit.
Okay. At the end, sir, 4 ohm resistor will not be considered.
Yes, it will not be considered because in that series branch, zero current is flowing. If zero current is flowing, that means it is open circuit.
Okay. And sir, you are considering that that inductor is not having any resistance.
Ideal. We are considering capacitor also ideal, inductor also ideal.
Okay, sir.
Ideal inductor.
Sir,
Yes.
sir, how come that VC is equal to the voltage across 5 ohm?
Okay. See, I can say this 4 ohm and capacitor combination is parallel to 5 ohm and inductor combination. Is that true?
Yes, sir.
Now, these 2 points are parallel to these 2 points. This became short circuit. That means both of them are parallel to 5 ohm.
Yes, sir.
Now 4 ohm is having zero current. So the drop across 4 ohm is
Okay.
zero.
Okay.
Okay,
Now I understand. Yes, sir.
fine. Okay,
Yes, sir.
right. So now series and parallel combination of inductor already known to you. Series combinations are very similar to resistor series combination, and parallel combination is also same as resistor parallel combinations. Is that fine?
Yes, sir.
And when we conclude, this is the table which you should remember and not confuse with, that for three devices that we have, or three components, resistor, capacitor and inductor, these are the voltage current relationships. This is power, series connections, parallel connection, and at DC, resistor will remain like resistor, capacitor will act like open circuit, and inductor will act like short circuit. And circuit variable that cannot change abruptly. In resistor, voltage or current, anything, they can change abruptly. In capacitor, voltage cannot change. In inductor, current cannot change immediately. So if you are trying to say that voltage across capacitor is constant and immediately it will drop to zero, that will not happen. It will go like a transient effect. Is that fine? Similarly, the current across inductor.
Excuse
Okay?
me, sir.
Yes.
Yes, sir.
Sir, in case of inductor, when we are calculating
Hmm.
I is varying from T naught to T, right?
Okay. Yes.
So, what is that value of I that we have calculated by integrating the function? Means what does it signifies?
This one.
Yes, sir.
This one says that this is the formula for current. Okay, this is the formula for current. And now, if I ask you what is the current at t equal to 2 seconds, put t
Yes,
equal
sir.
to 2 and I say my current at t equal to 2 second is 16 ampere.
So, sir, how we will be able to calculate the energy
Energy,
stored within 0 to 5
energy
seconds?
also we are asking how much energy in first 5 seconds.
Yes,
So
sir.
put t equal to 5. What is the value of 5 cube? 125 into 2. So current is 250 ampere and 1 by 2 Li square will give you the energy for
At
first
T
5
equal to 5
seconds.
seconds.
Yes.
Okay, sir.
Okay.
Yes, sir.
This I gives the particular at t is equal
I
to 20.
is changing at every time. Okay. So that is why we are also not asking that how much energy is there from 0 to infinity. Okay, now we have few questions. So there is a circuit given to us. For this circuit, IT, what is IT? This current is 4 into 2 minus exponential minus 10t. If I2 0, see what is I2? I2 is the inductor current and we are saying at t equal to 0 it is minus 1 milliampere. Find I1 0. That means this current at t equal to 0. Vt, V1t, V2t, I1t, I2t. All these equations and values we have to ask, find. Okay. Let us look at this circuit very peacefully now. There are 3 inductors. 1, 2, 3. And this is my total current I, and I is equal to I1 plus I2. Is this clear to everyone that I is equal to I1 plus I2? Okay.
Yes, sir.
That means at any time, be it time t equal to minus infinity or 0 or plus infinity or 10, this relation will hold. Is that fine?
Yes, sir.
Okay, now what are the things that are given to me? I am given the equation of I and I am also given the initial value of I2. In this equation of I, put t equal to 0. What do you get?
4.
4.
4.
4. See, e raised to power 0 is 1, 2 minus 1 is 1, 4 into 1 is 4. So this is I of 0. What is I of 1? I1 at t equal to 0 and I2 at t equal to 0. I2 at t equal to 0 is already given. So what will be I1 at t equal to 0?
4 minus minus 1.
4 minus
5.
minus 1, that is 5 milliampere. Is this correct? Is this fine with everyone?
Yes, sir.
So I calculated I0 and I already know the value of I2. I know I can calculate I1. So this is the first calculation done. Any issues till this point?
Yes, sir.
No.
No, sir.
After that, I need to calculate what are the values of V. So V is equal to L di by dt. That means I need to find what is L.
Sir,
This
in
is
L equivalent, it is written 2, and in circuit, it is written
It should
4.
be 7.
So there is slight mistake. If all the calculations are done with 2, I think everywhere it is done with 2. So it's better we change this to 2. And okay. So 2 plus 4 parallel 12. So this is 5. So L is 5 because then V is L di by dt. So 5 into this is my equation for I of t. Take di by dt, multiply with 5, and this is the equation that I got for V of t. V of t means voltage here. Now if I ask how much is V1 and how much is V2, so this is 2 ohm, this is 3 ohm, so accordingly they will go. You can divide them. Is it easy now? Can you divide V into V1 and V2?
Yes, sir.
If V is 200, V1 will be 2 by 5 of 200 and V2 will be 3 by 5 of 200. Is that okay?
Yes, sir.
And 2 by 5 of
Yes,
200
sir.
is 2 by 5 of 200 is 80 and 3 by 5 of 200 is 120.
So, may you explain this again?
Sir,
See, okay,
VT,
fine.
sir, VT meaning what is?
Wait. Uh, maybe you have some adjustment issues, so I will do one thing. Let me not take them as inductor, let me take them as resistor. Okay, voltage here is V, voltage across this is V1, voltage across these two is V2. These two are in parallel, they will become in series, and I will have total voltage V and two resistors. What is this inductor value? 2. So this is 2. What is the effective inductance of these two? That is 3. Okay. So if this is V, this is V1, this is V2, what will be the drop across 2 Henry? 2 divided by 5 into total voltage. What will be the drop across this 3 Henry? 3 divided by 5 into total voltage. Is that fine?
Yes, sir.
Or the other way of calculating is total current flowing is I, 2 into I in the first one, 3 into I in the second one. So now if we, this is done, this is done, this is done. What is the equation of I1? What is the equation of I2? How do you calculate that?
Sir, flux will be linked like Li1 equals to matlab 4 into I1 equals to 12 into
Right.
I2.
So this is total I1 is going here, I2 is going here. So just like resistor, you would make the current division.
Yes.
Okay, and you will get the equations of I1 and I2. Okay, you can do simple current division also.
Sir, if we use
Now,
that flux linking, then also answer will come right.
same. There are different methods of doing the same things.
Okay.
So now we have something called first order circuits.
Sir, please show the answer of I1T and I2T.
Okay, so you can note down.
Sir,
Yes, one thing you have to be very careful. One thing that you have to be very careful, that equation for current was 1 by L integration V dt. Okay, plus I naught. Don't forget I naught. So in when you are calculating the current across I1, this one, that means we are concerned about this. And what is the voltage across this inductor? V2. Okay. So 1 by 4 V2 dt plus I1 naught. So V2 dt was 120 e raised to power minus 10 t dt. 4 is here. And what was I naught for I1? That was 5. Similarly, for I2. I2 naught was minus 1. Okay. So note down these two answers.
Sir,
Yes.
sir, in case of the A part, we are not able to apply the current division method
Okay.
because we are getting I2 as -1 and I1 as 5. So current division is not valid here, or some other concept is applied.
Uh,
That is flux linking.
no, no. You are saying at t equal to 0.
Yes, sir.
So in the previous slides,
See. Okay, that current division simply by taking the inverse of inductance will not work because they are not pure resistors. Okay. So better is we go with the inductor equations only, which are the current and voltage relations. I is equal to 1 by L V dt. You have to be very careful that which voltage and which inductor value you have to take. Let us now calculate I2. In I2, inductor value is 12 and voltage is V2. V2 equation is this. Okay. So 1 by L means 1 by 12 V2 dt. V2 is 120 e raised to power minus 10 dt. And the value of I2 at t equal to 0, which is minus 1. Now you do one thing. You take this equation and this equation. First equation is 8 minus 3 e raised to power minus 10t. Second equation is minus e raised to power minus 10t. This is I1, this is I2. If you add both of them, what is the equation that you are getting? 8 minus 4 e raised to power minus 10t. That means 4 common, 2 minus e raised to power minus 10t, and which is same, which is given to us. Is that fine?
Yes, sir.
Sir,
So this
while
relation should always be true. I is equal to I1 plus I2.
while calculating the voltage, we treated them as ideal resistors.
No, I said that that is a layman kind of explanation I am giving to you. Okay,
Okay.
because equivalent inductance of inductors is very similar to equivalent inductance of resistors. So to calculate the equivalent inductance for a brief time, I said assume them as resistors.
Okay.
Sir, sir,
Yes,
if we taking the limit is from 0 to t, then why we adding 5 milliampere?
because 5 milliampere is calculated at 0 second and limits. See, limits will always be from minus infinity to t. Okay, 5 milliampere is calculated from minus infinity to 0.
Okay.
If I have the number from minus infinity to 0, now I need to add only from 0 to t. Is that okay?
Okay.
So,
Yes.
so then in which case we'll be able to equate the flux equations and get the answer from that the way we equated just before, that 4I1 is equals to 12I2. Then in which case we'll be able to get that answer with this respect?
In which case means?
Means I'm asking, if we equate the flux, then the equation would be 4I1 is equals to 12I2.
Okay.
Then I'm asking, in which case we'll be able to get the answers in this frame. Like here we got the answer by integrating. If we see the flux equation, then it's not satisfying the answer. So I'm asking, is there any case in which the flux equation will satisfy the answer?
There is another inductor also, 1 Henry. All
No,
three of them
two,
will be long branching.
two Henry also that we should also include.
So if three of them will be linked, then flux linkage will different.
Then only the equivalent circuit, and then you can apply.
Okay. Okay.
And you will start finding one thing, that till the point we were in class 11 and 12, the circuit part was mainly a portion of physics, and we used to talk more from the physical quantities point of view. Now, being purely towards the circuit theory, flux will be rarely used in electronic subjects, and current and voltage concept will be more prominent. So if you have seen till now, I have not talked about flux and fields and all, right?
Yes, sir.
So slowly we will start migrating from one kind of concepts to other, although they were the main causing effects, but now we are mainly concerned about that what is happening because of them. So I think that time is up. Yeah, already up. So next time we'll start with the more circuit analysis, first order circuits. You would have already studied these. That means what happens if I have one resistor and capacitor combination, how the charging and discharging will happen, how time constant of charging and discharging. Have you studied all these, right?
Yes, sir.
Yes,
Yes, sir.
Yes, sir, but they were not clear that time.
Fine. So we'll go a little slow on that. First order circuit using RC and RL,
RLC,
both of them.
RLC, and all.
And I'll do one thing, because now you have a weekend. I'll upload these slides in advance, so if you have time, you can study these. Okay?
Yes, sir.
Yes, sir.
And the Moodle thing, I talk to the team. Hopefully, you will get the roll numbers by this weekend. And if you get the roll numbers, then I will give you your personal Moodle accounts, and practice quiz is already available on the course. Then you will be able to take that. Okay?
Yes, sir.
Okay, then. So then we will.
Sir?
Yes.
So for basics electronic course, you suggested this book by Matthew N.O.